Okay, so for segment B of this lecture, I thought I would take that last problem and show you how to do it if you don't have a conversion factor that will allow you to do it in one step like we did. We had a conversion factor between meters per second and kilometers per hour, which allows you to change the top unit and the bottom unit at the same time. You can change kilometers to meters and hours to seconds simultaneously using this conversion factor. This conversion factor is actually sort of a combination of several other conversion factors, the ones that you would have to use if you didn't know how to do it all in one step, or if you didn't have that conversion factor. You'd have to use all the conversion factors that went into making up that number. So if we want to do it separately, we have to consider the top unit and the bottom unit, that is the distance unit and the time unit separately. And we first have to convert kilometers to meters, and then we have to go back and convert the units on the bottom. That would be hours to seconds. And that's actually not too difficult, but it's certainly more difficult than doing it this way. So here's how you can do that. First, you take the measurement given. But if you're going to convert the top and bottom units separately, it would be a really good idea to rewrite what you're given in terms where it makes explicit which unit is on top and which unit is on the bottom. So 150 km/h can also be written as 150 km over 1 hour. And so I would start by writing it like this. And what we're going to do is focus on the unit on the top here and convert kilometers to meters and just ignore the hours for the time being. And they'll just sit there unchanged as long as you don't do anything that actually changes them. Okay? So we know that kilo means 1,000. And we want to get rid of kilometers, and we want to make it meters. So that means kilometers goes in the bottom of the first conversion factor, and then meters goes in the top. 1 kilometer is 1,000 meters. That's what kilo means. It means 1,000 of something. So a kilometer is 1,000 meters. Now notice that we've gotten kilometers to cancel out. And if you want to stop and write the answer down now, you can do that, and you would have meters per hour. In fact, why don't we do that? So 150,000 meters in 1 hour. And I've written that down now just because we've finished converting the top unit, but we haven't done anything with the bottom unit yet. So now what you can do is come down to the next line, or just keep going along like that. And we have to change hours to seconds. And this is going to be a little bit challenging because so far we've always been converting units that are in the numerator. Well, converting units in the denominator works exactly the same way, except everything is upside down. If you want a unit in the denominator to cancel out, that unit has to be in the numerator of the conversion factor. And we're not going to do anything with the meters because that's the unit that we want to be on top. It's only the unit on the bottom that we have to change now. So let's see, if we can find a conversion factor directly between hours and seconds, that would be nice. There are 60 seconds in a minute and 60 minutes in an hour. So, well, we could do it that way too. 1 hour for every 60 minutes. Okay. So hours cancel. And if you want to write down the answer now, you would have meters per minute. But we're not done yet. We want that unit on the bottom to be seconds. So you don't have to stop and write down an answer after every step. You can keep right on going and doing more conversions until you finally get the units you want. Okay, there's 1 minute for every 60 seconds. So now minutes cancel. And we have seconds in the denominator. And we have meters in the numerator. And so if we take 150,000 divided by 60, and then I hit equals after dividing by something just to play it safe. And then take the answer and divide by 60 again, we get 41.6 repeating, which is basically 41.67 if you want to round it off to 4 significant figures. That is too many significant figures, though, because if we look back, okay, in terms of significant figures, remember 1 minute for every 60 seconds. Those are exact numbers, so because that's a definition. One hour for 60 minutes, that's a definition. Those are exact numbers. 150,000 was the result of step 1, so that doesn't matter for significant figures. The 1,000 meters per kilometer is the definition. That's an exact number, so that's infinite significant figures. 150 with no decimal point. That's only 2 significant figures, so our answer needs to be 2 significant figures. That means 4 and 1 can stay, but 6 has to go. 6 is greater than 5, so the number before it has to become greater by 1. And what do you know? It's 42. And also, what you'll notice is if you take all of the conversion factors in these 2 equations here and multiply them together, so that is leaving out the first terms, if you take 1,000 divided by 60 divided by 60, what do you think you get? You get 0.277777 on to infinity, which rounds off to 0.2778 to 4 significant figures. And so that is indeed where that conversion factor came from. It's a combination of this and this and this. Okay. Okay, so moving on to the next example, let's see, that was number 5. 6 is convert 18 cubic feet to cubic meters. So this is another one that there are a couple different ways to do it. And if you can find the conversion factor, the right conversion factor to do it all in one step, you know, so much the better. And let's see, in the cubic feet and cubic meters, that is length or distance units to the 3rd power would be units of volume. So look under volume, and we see down at the bottom of the volume section, 1 cubic foot is equal to 0.02832 cubic meters. So that's what you're going to want to use. And so we just start with what we're given, 18 cubic feet. And I'm going to write that over 1 just to remind ourselves that it's in the numerator. And then we can use our conversion factor. And we want cubic meters, so the 0.02832 cubic meters goes in the numerator, and we want to get rid of cubic feet, so the 1 cubic foot in the conversion factor goes in the bottom. That means cubic feet should cancel out, and we get 18 times 0.0832. Oh, sorry. 18 times 0.02832, and that is 0.50976 cubic meters. Too many significant figures because of this we can only have 2. So that's going to be the 5 and the 0. Everything else has to go. The first number you're dropping is 9, which is greater than 5. So the number before it has to go up by 1. So that's 0.51 cubic meters. And there you go. There's another way to do it. because you don't necessarily have to use the conversion factor that goes directly from cubic feet to cubic meters. There's another conversion factor that goes from feet to meters. You can actually use that and cube it, because that's actually what this number is. It's the conversion factor between feet and meters that's already been cubed for you. But it's good to know how to do it in the more basic fundamental way, just in case you can't find the the cubic the conversion factor that's already cubed when you need it. Okay, so you can actually just use the regular conversion factor between meters and feet. For that, we go back to the conversion table. We look under length, and let's see, meters and feet. 1 meter equals 3.281 feet. So we can use that also. If we've got 18 feet to the third power, and that's going to be over 1. We're going to use our conversion factor. We want feet in the denominator to cancel out with these feet. So it's 3.281 feet, and that's 1 meter for every 3.281 feet. And now, since we've only got feet here, not cubic feet, we can get cubic feet out of this conversion factor, and we can get cubic meters out of it by cubing the conversion factor, the entire thing. The only thing you have to remember is that cubing applies to the units, but also it applies to the number. So when you come back through and do the math, you have to be sure that you cube that number when you divide by it. So this means that cubic feet will now cancel out, and we should get cubic meters as the unit, and 18 divided by 3.281 raised to the third power, which I would do like this, if you can see that on the video, divided by parenthesis, 3.281 raised to the third power, close parentheses, and then hit equals, and we have 0.5096 and so on. .509628.625. Obviously, too many significant figures. It looks like it's a little bit different from the number we got before. But remember, we're only allowed to have 2 significant figures here. When you take this number and round it off to 2 significant figures, guess what? It becomes 0.51, just like it did before. And you'll notice that if you take 1 over 3.281 and raise it to the third power, what do you get? Oops, 0.0283, well, 1. So pretty close to 0.02832. So it's really the same thing you're doing. You're just kind of writing it in a different way. Okay, next, 220 centimeters to feet. That's a fairly simple one. (220 centimeters to feet). Our conversion factor will come from the conversion factor sheet under units of length between centimeters and feet. There we go. 1 foot is equal to 30.5 centimeters. Oops, okay. So we start out with what we're given, 220 centimeters, and I'm going to write that over 1 just to remind us that this is in the numerator. We need our conversion factor, and then hopefully we'll get something in feet. Okay, for the conversion factor, we want the centimeters on the bottom, and we want the foot on top. So the centimeters will cancel, and we'll end up with feet as the unit. 220 divided by 30.5 gives us 7.213114754, which is obviously too many significant figures. Now, you do have to be aware of significant figures, and you do have to cut the answers down to the right number of significant figures. You don't have to necessarily do what I've been doing and writing down every digit that your calculator spews out at you. You could round it directly on the calculator and then just write it down and correct significant figures on the paper. But anyway, this definitely should only have two significant figures because you notice the 220 doesn't have a decimal point. So the 0 at the end doesn't count. That means the 7 and the 2 can stay, but everything else has to go. First number we're dropping is a 1, so that has no effect on the numbers before it. 7.2 is what we got here. 7.2 feet should be what we get. Now, we happen to have access to a conversion factor between centimeters and feet. Not all conversion tables do, although actually since we've got basically open book tests and quizzes, you can always use the conversion factor table from the math handout for anything that you need to do. But suppose you lose it, you're losing some other book that only has a few conversion factors in it. Suppose we don't have the one that goes directly from centimeters to feet. Well, you can do it in other ways too. Like I said, there's practically an infinite number of ways to do unit conversions. It's just that some of them might require more than one step. And so we'll see how to do this if you have only a limited number of conversion factors available. about that, and Cultural Revolution. Ever heard of that?
Well, they've never heard of any of it. They just hear these basic.
They don't need no fucking virus to kill people. They just do it.
Listen, dollars, facts and dollars.
Apparently my class is finally getting started. And put a semicolon after every address. Otherwise, it thinks it's all one big address. And then I can say. Well, there is that thing out the bottom of the bandwidth that says all classes. Now that's the kind of shit Bill Gates is, not virus. Okay, so that was centimeters to feet. And next we have number 8, where we want to go 55 feet per second to meters per second. Notice in this case, these are compound units. We got unit on the top and a unit on the bottom, but we're not actually changing the unit on the bottom. That makes this effectively just like a regular everyday unit conversion, where you really just have to go from feet to meters. You can look in the on the conversion sheet at the end of the math section and see if there's any conversion for feet per second to meters per second. This would be under speed because it's distance divided by time. And sure enough, the second entry under speed on the sheet here, on the conversion sheet here, is 1 meters per second equals a bunch of different things. But at the very end, we see that one of the things it equals is 3.281 feet per second. Okay, so that's a conversion factor we can use. 55 feet per second is the number we're starting off with. Again, I'm just going to emphasize that that's in the numerator. And then we'll have a conversion factor, and then hopefully we'll end up with meters per second. Okay, so for the conversion factor, we want feet per second in the denominator. Whoops. So 3.281 feet per second in the denominator and 1 meter per second in the numerator. Feet per second will cancel out, leaving us with meters per second for the answer. And if we take 55 divided by 3.281, we get 16.76318.196. Yeah, that's really long. Especially considering we're only allowed 2 significant figures because of the 55. So that means the 1 and the 6 can stay, but everything from the 7 on has to go. And the first number we're dropping, though, is a 7, and that means that because it's greater than 5, the number before it has to go up by 1. So that becomes 17 meters per second. Okay, so 17 meters per second. Notice in this case, though, that we are really only changing the unit in the numerator. So since we don't have to change the seconds, we're effectively just changing from feet to meters. And if you go back a couple of problems to where we changed from meters to feet, you'll see that this number here is the same number as in the conversion factor. That's just between meters and feet. And again, that's because that's essentially all we're doing here. Okay, for 9, we've got 95 cubic centimeters to cubic inches. Okay, so we look for the conversion factor. Length units to the 3rd power would be units of volume. So we're looking under volume in the conversion factors, and we're looking for a relationship between cubic centimeters and cubic inches. And second one down, 1 cubic inch is 16.39 cubic centimeters. Okay, so what we're going to do here is take 95 cubic centimeters. That's the number we're starting out with its units, times a conversion factor. The conversion factor will have cubic centimeters on the bottom because we want those units to cancel out with the measurement we started out with. And it'll have the 1 cubic inch in the numerator. So cubic centimeters will cancel out, and we have 95 divided by 16.39, and we have 5.796217206 cubic inches. Because of the 95, though, we can only have 2 significant figures. So that would mean the 5 and the 7. Everything from the 9 on has to go. But notice that the first number we're dropping is greater than 5, so the number before it has to go up by 1. So 5.8 cubic inches would be the equivalence. The conversion factor that takes you directly from cubic inches to cubic centimeters is one that you don't see listed in very many conversion factor tables. Fortunately, the one that we got is a big one. Actually, the conversion factor table at the end of the math section is taken from the inside cover of the textbook also. So when you get the textbook, you can look at that and see that. It's basically the same thing. Much more common would be the conversion factor between the linear or one-dimensional units. 1 inch is 2.54 centimeters. That is much more commonly seen. That's listed in just about every conversion factor table everywhere. So you could also use that one. You just have to cube it in order to make it apply to cubic inches and cubic centimeters. So we have 95 cubic centimeters, and our conversion factor, we want centimeters on the bottom, which is on the bottom there, and 1 inch on top. And now centimeters and cubic centimeters don't cancel out with each other. So we need this factor here to apply to cubic centimeters. And we also need it to apply to cubic inches. But if we're going to cube the units, we have to cube the numbers too. And we can do that simply by putting a 3 outside the parentheses. That 3 there, and I'm going to circle it just to emphasize it, applies to everything inside the parentheses. Okay, so now this is cubic inches, which will cancel with cubic inches over there. This is now cubic inches. So did I say cubic centimeters? Cubic centimeters cancel with cubic centimeters. Cubic inches will be the unit for the answer. And 95 divided by 2.54 to the third power. So I would do it as 95 divided by 2.54 raised to the third power, close parentheses, and then you hit equals, and we get 5.797 255,689. Again, much too long, but it's very similar to this number. Not exactly the same because we rounded off some things a little differently. The only differences, though, are well beyond the number of significant figures we're supposed to be using. If you round this off to 2 significant figures, it also becomes 5.8. So the numbers are exactly the same up to the limit of the significant figures that we actually know. And one reason that you can do it either way is because 2.54 to the third power is actually 16.39. That number there rounds off to 16.39 when you cut it off to 3 significant figures. I mean 4. Okay, so we got some more conversions to do, which we'll pick up in the next segment, but I think this one has gone on long enough. So I'll see you in a moment.